For today's video, you'll need IC22. This is the day where we are going to take our flowchart proofs that we've been writing for congruent triangles and transition over into our official two-column format. This is going to be what your problems will look like when you eventually take your assessment over this topic. So to get us started, let's talk a little bit about two-column proofs. They are going to involve organizing the statements and the reasons that we've already been practicing in our flowchart proofs, but they are organized side by side rather than from top to bottom like they are in a flowchart. The reason why we transition to two-column proofs is because this format is more flexible. We're going to pretty quickly move into proofs that don't fit this kind of 3 bubbles, 3 boxes, 1 box at the bottom format. And so flowcharts will be a little bit more time-consuming or tricky to use because they wouldn't all fit in this type of a format. But no matter what proof we do, we're always going to be able to just list in a logical order statements and reasons side by side to support whatever concept or idea we're trying to prove. So what we're going to do to get started today is actually a review exercise. So in a moment, once I give your instructions, you'll pause the video and you'll work your way through this to kind of double check that you know what you're doing. But you are going to focus on this given and prove with this diagram. And the goal is for you to be able to fill in the flowchart side of these notes. So that's something we've practiced in class. Go ahead and pause the video and see what you can come up with in terms of a flowchart proof for this particular situation. Okay, we're going to check your work and see how it went. If C is the midpoint of segment BD, we're going to focus on that bottom part of the diagram, and midpoint should tell us about congruent segments. As it is given to us, though, C is the midpoint of segment BD does not give us congruent sides or congruent angles, so it needs to belong in one of these 3 bubbles, it doesn't matter which one, with the reason given in the blank directly below. And then directly underneath that, we're going to write what it tells us. So if your midpoint given is over here in the middle, you should be looking at your middle box next. Or if it's over here on the right, you should be looking at this right-hand side box next. What we marked was that segment BC is congruent to segment DC. Now you might have these letters in a different order or these letters in a different order. That's fine. I'm going to mark that with an S. Again, that's not required, but it's reminding me it's a pair of congruent sides. And the corresponding reason to go along with that would be definition of midpoint. Again, if you're not supposed to abbreviate definition, just go ahead and write that out, and then you can put midpoint down below if you need more space. So that uses our first given, so that one's taken care of. We're going to move on to given number 2 here, which does look like it already has a congruent symbol. So if I mark segment AB congruent to segment AD, that looks like it's automatically a pair of congruent sides. So I'm going to skip that bubble. It's not going to be necessary. And that's going to go directly into one of my boxes. And the reason I knew that was true was because it was given. So I've successfully used both of the given pieces of information. My goal is to prove that the triangles are congruent, but I don't have enough to match one of my 5 criteria yet. Remember, our goal is going to be side, 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 or side, angle, side, or angle, side, angle, angle, side, or hypotenuse, leg. So far, we have 2 S's, so it's looking like these are probably the most likely, but we don't have that 3rd pair of sides, and we don't have an angle, so we're not quite ready to make our conclusion yet. When you don't have any givens available, you come back to the picture. Hopefully you notice that there's a shared side here. Segment AC is used in both triangles. So we can mark that segment AC is congruent to itself. Segment AC is congruent to segment AC. That's a 3rd pair of sides not given to us, but something that we noticed by looking at the picture. When we say that shared side is congruent to itself, it is the reflexive property. Now that I see my three S's lined up, I know I'm ready to make my conclusion that triangle ABC is congruent to triangle ADC by side angle side. Okay, so hopefully that went well for you when you stopped and you tried that on your own. We are now going to take this and show you what a two-column proof looks like for the exact same problem. So we're going to start the same way we started before. C is the midpoint of segment BD is a statement that's being made about this situation. So we're going to fill that in as our first statement in the left-hand column. We would investigate that part of the picture, we would mark it, but we would also need to write next to that the reason we know that was true is because it was given. Now the goal, if this is not a pair of congruent sides or angles, is to automatically make that happen directly below. So this information should lead you to a new statement based on that definition of midpoint, since we see that vocabulary word in that statement. And so we would list, just like we did directly below it in the flowchart proof, that segment BC is congruent to segment DC, the ones that we marked along the bottom part of that picture. And then if you want to keep track, since there's not a box for you to put an S in, you can just kind of put that out there next to the proof. That's a pair of congruent sides. We've used the midpoint given now and turn it into more useful congruent sides. So we're going to move on to our next given. Segment AB is congruent to segment AD, just like we wrote in that box. We can label that with an S since it's a pair of sides. And we can say that we knew it was true because it was given. Now, just like before, we're done with our givens, but we only have two S's lined up. So we haven't matched any of our 5 criteria. So we go back to the picture. We notice that reflexive property shared segment. So we're going to write segment AC is congruent to segment AC in our next line of the proof, thanks to the reflexive property. Label that with an S because it's a pair of congruent sides. And once our 3 S's are ready to go, we can finish out this proof by saying that triangle ABC is congruent to triangle ADC by side, side, side. So it is the exact same 1, 2, 3, 4, 5 statements, just vertically organized, and the same 1, 2, 3, 4, 5 reasons directly across from what they are explaining as we move down that proof. If you flip to the back side, we're going to try that again. So go ahead and pause the video, try to do the flowchart version of the proof, and I'll meet you back here to talk about how to turn it into a 2-column proof. All right, everybody, we have one more example to take care of in class 22. We're going to go through another round of putting together a flowchart proof and then turning it into our new 2-column format. So for this proof, we are using the same picture as the other side, but we have completely different information. So first up, triangle BAD is isosceles with base BD. So that's talking about this entire outer triangle. If the base is BD, remember that means that in an isosceles triangle, the other 2 sides are going to be congruent to each other. So I think we're ready to get started. This is a vocabulary word that doesn't yet tell us about congruent sides or congruent angles. So that's going to be bubble information. So we're just going to copy it exactly as it's written into that bubble. You know there's not a lot of space, so just try to do your best to fit that in. And the reason we know that statement is true is because it was given to us. But then it tells us about a pair of congruent sides. Segment AB is congruent to segment AD and those are sides in our triangles. That's based on the definition of isosceles triangle. We know an isosceles triangle always has two congruent sides, so we're using that definition to get our first set of congruent sides. Okay, next up, we're running into right angles, which in my opinion are always tricky, because depending on what kind of proof we do, we may use these right angles for two completely different reasons. But for right now, we're going to write down in our bubble that angle ACB and angle ACD are right angles. We've learned that right angles are always bubble information. That was given to us. And I'm going to go over to my picture. Angle ACB is this angle here on the left side of the picture, and angle ACD is that angle there on the right side of the picture. And then I'm just going to leave this open for right now because I really need to make a decision on whether this is a hypotenuse leg proof or whether it's a different kind of proof to know what I need in this spot. It's either going to be some right triangles so that this will turn into an H or an L, or it's going to be that these right angles are congruent so that I can use it as an A, maybe for side or angle side angle or something like that. So let's move on and see what else. No other givens. So we're on the lookout for either reflexive property or vertical angles theorem. I'm noticing this shared side AC here. So this is going to be a reflexive property proof. We're going to go straight to the box with that information. Segment AC is congruent to segment AC. That is another pair of sides, thanks to the reflexive property. Okay, now even though I have this empty space here, I'm going to try to see, based on my picture, what my final reason is going to be for these congruent triangles. And then we can go back and we can fill in that empty space underneath the right angles given. If I'm looking at what I have so far, I have two pairs of sides congruent, and then I could use these as a pair of congruent angles. So that would mean side angle side, but if it was side angle side, I think those angles would need to be up here at point A, because that would be where all of my congruent sides are intersecting. Instead, if I imagine my little across from the right angle test, these are actually the hypotenuses of these two triangles, and then my reflexive property side is the leg. So I'm going to need to change this S to be an H, and I'm going to need to change this S to be that L for leg, which means HL is going to be my final reason, but I have to fill in this missing piece. In order for legs, or in order for a side to be called a hypotenuse, we have to have right triangles. So we're going to change this statement just slightly to show that triangle ACB and triangle ACD are right triangles. That's what allows me to get rid of the S label and make it a hypotenuse label. So that is the only time we have information in one of these boxes that isn't a congruent symbol. That's the definition, of right triangles. And that will always show up after our right angles when we end up doing a hypotenuse leg proof. Okay, so now that we've got it all outlined and ready to go, all we need to do is turn it into the two-column format. So just like before, we started with this isosceles triangle given. So we're going to copy that exactly as is. And we will mark that that is a given piece of information. Remember, originally we labeled that with an S, so if we're kind of tracking through, oh, we didn't label that with an S yet. We turned it into, sorry about that, congruent sides. AB as a segment was congruent to segment AD, thanks to the definition of isosceles triangle. That's what we labeled with an S originally. So if we're going through the same thought process, we just kind of label it with an S and we keep going. Then if you want to use the right angles next, you certainly can, but remember we're not really going to know what to do with those yet. So in this 2-column proof, we're just going to leave a space after it because we know we're going to do something with it, kind of like those isosceles fact turned into the congruent sides. This is going to turn into something, we're just not really sure what. So leave that space open. And then we're going to pull in our reflexive property. Segment AC is congruent to segment AC, which we also labeled with an S originally. And then either this would turn into an A, which means I would be ready to finish the proof, or it's going to turn into what I need to change these to be H's and L's. That means I'm ready for my triangle statement. So we can go ahead and say triangle ABC is congruent to triangle ADC. I just need to decide what I'm going to use here as my reason and then go back and fill this in. So as a reminder, we looked at this and we said, well, if it was side angle side, we would need the angle to be at the top, and it's not, which means we don't need these to be congruent angles. With right angles theorem, we need these to be right triangles. So triangle ACB and triangle ACD are right triangles based on the definition of right triangles. And that allows me to go back to side AB and AD up here and call those two hypotenuse sides. And it allows me to go back to my reflexive property, segment AC congruent to AC, and call those congruent legs to finish it out with hypotenuse leg. All right, that's your second example of transitioning from flowcharts to 2-column format. We will see you back in class.